My name is Caroline Lama. I work for ARUP. We're a building engineering firm, and we have international offices in about 40 countries. We're about 10,000 people, and I work in the New York City office for the facades group. So I do facade engineering as well as building physics consulting. We feel a lot of pressure from the sustainability side of things. There's a lot of pressure on building owners now to provide green building spaces for their occupants. So that really affects the engineering of the facade as well as all of the other building services. Our architect clients always want to use the newest, the latest, the greatest technologies, and this sort of requires us to do a lot of research and to really work hand in hand with the fabricators and manufacturers as well. The project I presented at the conference was a lab school in Chicago, and we did computational fluid dynamic modeling of the library space, which was a very large, complex space, and they had concerns about occupant comfort, and so that's why we did the study. And to pre-process the model before doing the CFD, we used HyperMesh. The first thing was that the geometry itself was very complex, so the architectural design intent presented a challenge in and of itself. The second thing was that some of the new technologies they were using required us to use very refined mesh spacing, and so that created a big range of mesh cell sizes that we needed to accommodate. HyperMesh is a very solid product, and it gives the user a lot of flexibility, which I appreciate. It provides multiple ways to do the same thing so that you can really customize your process. Certainly HyperMesh has reduced the time it would take to build a mesh, and it's enabled us to build a lot more complicated meshes than we could have before. And I think that the more power you have, the more quickly you can arrive at your answer, and the more complex analyses you can do.